Cafe Rio gang. Okay, now they get Cafe Rio. Right on. You know, I'll give them this. They're the chicken barbacoa, pretty delicious. Yeah, if you're a meat eater, I am. All right, I am recording, unfortunately, and I'm going to share my screen and let's do this. So I've just prepared a couple of things. I'll show you what those look like, and then we'll go through them, do them by scratch. Once I'm done, I'll upload this to YouTube and get it onto Canvas. But so we're going to talk about a couple of different ways you can begin to think about your scanner envelope. This is not the only way you can, but when it comes to, let's say, thinking about, for instance, curtain wall, some sort of panelizations. I've done a few things in Revit as well as Rhino, and so I'll just sort of talk about that and show you kind of where we're going to go, and then we'll do this from scratch, step by step. So just waiting for this file to open, which is weird because it was working just fine not too long ago. And I literally was working on this for the last hour and a half or so. What's annoying is I was trying to figure something out and I never did for one key thing. I guess that's a weekend project for me in between doing some gardening and cleaning the house. Come on. I'm kind of getting nervous here. I don't know why this is taking so long. It's not a particularly huge file or anything. All right, unable to zoom, no objects available. Okay, because I have everything turned off. Perfection. Okay, so I took a piece of in this case, I think it was some sort of figure 8 Klein bottle thingy majigger. So I sampled, like, if you thought about the sort of figure 8 being swept around another figure 8 or something, it's kind of a weird thing. I sampled just a sort of slice of the pie, so to say. And so you can see, before I started to break this up into 3 different sort of surfaces, this was one surface that sort of intersected itself right here, right? I broke that up, and I'll show you how I did that in a moment. So we'll jump back to this position to start with when we start to do things step by step. But I just want to sort of show you how I approach this. So first of all, when I was starting to bring things into Revit's really particular when you're importing SATs, 3DMs, and other sorts of geometry. Revit doesn't like to do inside out or self-intersecting things. So Revit right out of the box will not let you do something unconventional. And so that's why I started to trim this thing up. I brought it into Revit. We'll talk about that process. And what I did in Revit was essentially to take a portion of this and turn it into a curtain wall. So here you can see the glazing. There you can see what I guess was part of the other thing that I sort of offset into a sort of shell. There we go. Curtain wall, mullions. I'll just sort of zoom in on this a little more so you can see it better, right? So in this case, I took something doubly curved and instantiated a curtain wall system across it. You can see there really are sort of, I think, 2-inch mullions running across this thing. You can see that the glazing, and actually, well, it's actually kind of particular. It's pretty interesting how Revit sort of handled this. In some places, it handled it like a pro, and in others, not so much. Oh. Which is kind of interesting. I'm not here to judge Revit. I gave it a pretty hard scenario to try to resolve here. geometrically, but anyway, so I ended up with something like this from a curtain wall. Again, these are two different sort of systems. I don't like, maybe I was using different parameters for them at the time because I did them at different times. As well as sort of offsetting something, given it thickness. Right, so this could be pretty dynamic space where the outside is actually solid because it's facing the sun, and then, you know, facing a sort of courtyard over here on the right hand side, I have basically glass, something like that. You know, I was just sort of ad-libbing here on what this could be, since I was just sampling a portion of it and without a whole lot in mind. Didn't want to take too long, just sort of, you know, thinking of some sort of hypothetical. Let's see here. All right. So I'll talk a little bit about that back and forth between Rhino and Revit. I'll take this, we'll bring it into Revit. I'll show you how to do that step by step. It's not intuitive, in my opinion, unless you're really into Revit and really into or importing things from other places into Revit. So we'll talk about the nuances of that, as well as what you can do inside of Revit. Another thing that Revit had a hard time doing is I could make sort of curved geometry walls, but it wouldn't let me do wall reveals in them, which is a real pain, because that's how I like to do maybe like sort of aluminum panels, or, you know, some sort of zinc plated panel bond or something. And so, you know, it ended up having to do some things in Grasshopper that I thought otherwise I could probably just do with a couple of clicks in Revit. So here again is another set of examples I did this time in Grasshopper. So, and I'll show you guys again. I'll build that from scratch. What I did is I took the original massing. I took this sample for what I wanted glazing curtain wall to be. I rebuilt it in Rhino. You can see it's, for a rebuild, as a 1 degree surface. In other words, it's faceted. It matches up pretty well, and we'll talk a little bit about that. What I had to do is essentially rebuild this patch of the surface, so that since it's a trim, it kept wanting to sort of like instantiate across the whole thing. And so I just quickly rebuilt it. I'll show you some steps on how to do that really quickly, so it's not such a horrible ordeal. I offset this a little bit so that I have a sort of typical geometry, and then I have where the glass would actually be. I.e., I used the original poly surface here. Oops. There we go. Maybe. To instantiate the mullions, and then I used the offset version as actual glass. Let me just turn the Isoparms off on that so it looks a little cleaner here. Yeah. Let's see. Extracted wireframe. And then from there, it was making some quick mullions. Then from there, offsetting them into giving them some thick mullions. So you can see this system. This one lined up a little better when it came to how I was constructing it geometrically, where you have these nodes, everything sort of matches up nicely. There are ways to fix that stuff in Revit. I'm just not a Revit expert. In fact, if you just Google it, you can find some YouTube videos on just that. Freshly baked mullions. I love some freshly baked mullions. All right. So there is the Grasshopper curtain wall. You know, and then I sort of rebuilt the shell as well, and then offset that. Another thing when it comes to, you know, for instance, something solid like this, not only did I offset it, but then I took it and I began to panelize it. So in this case, I turned it into a series of skewed quads. So I have all of these sort of seams and things like that. I mean, when you have a big expanse of like wall or roof, I mean, you understand that these things are actually made up of lots of smaller parts, and all of those have joints and seams. And so, you know, I think that's one of the things I notice a lot particularly when I critiquing third year work in our school. It's like, that hasn't really set in yet that, like there's line work and sort of joints and shadows and reveals and things. So anyway, I'll show you how I did that as well. That didn't take too long. And if you're using a plugin like Lunchbox Tools, there's a bazillion different options you can use for sort of how to take a sort of large piece of geometry and break it up into smaller paneling. And you can see that this actually, all of these are planar. That's a shortcoming here. When you're doing the double curve geometry, when it gets really sort of concave or convex, then that's where you have a breakdown. Actually, these are quads, so they're not necessarily planar. But anyway, we can compensate for that with some triangular geometry instead of quad geometry, if that seems to be a difficulty. But so anyway, I just wanted to sort of show you where we're going here. I started with and meticulously made sort of copies and tried to be meticulous with my layer management, so that I always have this sort of original geometry if I need to go back to it, if I need to sort of generate something else from it, mullions versus glazing versus shell geometry, or panels or etc. Right? So if I need to offset something, whatever, I'm always one to sort of keep that original geometry. Even if it's in a different file, I can always import it back in. So let me just save that, and I'll turn some of this stuff off. Okay, here's where the file starts to get heavy, when I have everything turned on all at once, I guess. So I'm going to turn all of these things off. Let's go back to the beginning. Let's talk about the details and the nuances of everything that I'm about to do now. Okay, right. So I'm just going to open up this example. I think I have an example before I started to trim things and split things up. Right, so here this is like a figure 8 Klein bottle. That inside is really sort of a wicked, look at that. I mean, there aren't too many sick, nasty things in this universe, but I think the figure 8 Klein bottle might be one of them. I mean, it's subjective, but I'm not usually wrong about those sorts of things. Anyway, so yes, let's see. What I did is I simply started to cut a slice through this. Let's go to the top and side and get all 4 viewports. I'm just going to go ahead and get these extra toolbars out of the way. And in this case, I think I'm just going to draw like a box, all of this stuff, and it usually comes down to like drawing a box around it or something. It's the ironic part. And I don't know, maybe I'll just try to pick a piece like through here or something. I'll start with a slice like that, see what happens. I'm just going to use this to trim other parts of the surface away. So it helped if the box actually went all the way through the surface, wouldn't it? Go ahead and move that down in elevation. There we are. Now in perspective, I think we can get a better sense of what we're dealing with here. All right. All right, trim away. I'll just trim that part too. Yeah, see that now you know why it's called a figure 8, right? All right. Just delete this part away. I am not going to deal with this situation right now, but suffice to say, I was looking at this and I was saying, man, that's either a very highly sculptural centerpiece, or maybe it's the core, or maybe I blow this away and then have these things situated around emptiness or something else. But what I'm going to do is I'm just going to look at one wing of this. So I think I'm going to duck out for a moment for the sake of our demonstration. I'm just going to draw another box and start trimming this part away right here. Maybe. There we go. Down you go. All right, and let's see, split. I'll split this with this. Yeah, sounds about right. Huh. There we are. Now you notice that where I split, it's kind of awkward in that you can see where the isoparms are, and I didn't split along those isoparms at all. I sort of drew a pretty arbitrary orthogonal box in a couple places. So maybe I undo that, and I'll show you a different way to begin to split things with the geometry of the actual surface. So you can see I sampled a slice here. Maybe I'll even go back and do the whole thing like this. Yeah, go ahead and just take a look. So anyway, as I start to sample, let's say a slice, later on I can, well, here, sorry. Let me just redo. So yeah, I'm always going to make this, it seems like harder than it has to be, of course. Redo multiple? Ah, okay. Never mind then. I'll just do it this way. So one of the things I'm going to do is I'm going to look at how to split this thing up. And one of the ways I can do that, first of all, this is a periodic shape. So if I want to split it, I need more than one curve. In other words, I need to split it, like take a slice out of it, as opposed to just trying to sort of split it open. So you can see that there's actually natural seam here because it's a surface that sort of wraps in on itself and then meets back up at the end. So what I'm going to do, first and foremost, is I'm going to go to these tools. The one that's showing at the top is here is called Project Curve on Object. But in other words, we can start to use or find curves in surfaces here. So the first thing I'm going to do is I'm going to say extract isocurve. Okay, it's this icon that shows the isocurves in both directions along a surface. The command, when I click the button, so if you're interested in just typing the command or starting with the command, extract isocurve, not a huge surprise there, no spaces, all one word. I'm just going to select this surface, and now it's going to let me, I don't know if you can see my cursor, but I'm dragging basically a figure 8 along the length of this thing. And if I click in a particular place, I can start to actually create curves. Like let's say there and there. I don't know if you can see those magenta curves. So now what I'm going to do is I'm going to say trim, and I'm just going to select this curve. Oh, try to select the other curve here. There we are, these curves. I'm going to try to select something out here, right? All right, now I've sampled a piece of the surface. Just going to delete those curves away. There we are. Again, I'm not going to even bother with trying to do curtain wall here. And so here's a problem, right? I have a figure 8. So this thing intersects itself, no doubt, right? And so one of the things I'm going to have to do is figure out how to split this up so that it's not, I don't mind these things intersecting, but they can't all be one whole, just part of one entire surface, right? Well, it's a little hard to say, but what I'm going to do is I'm going to split it up so that it's multiple surfaces. And they just happen to coincide at this point, or one surface crisscrosses another surface, but it's not intersecting itself. Okay. And then this poses a problem if I'm going to bring into Revit as well, is that this sort of twists in on itself and intersects in a couple of different odd places here, as you can see. So I'm going to do a little more selective trimming here. For this case, I'm just going to go extract isocurve. I'm still drawing figure 8s in the, let's say, the U direction. So I'm going to say direction, and I'm going to pick V instead. See what I did in my command line. And now I can, do the opposite direction. Let's say the sort of latitude instead of the longitude, for instance, is one way of thinking about it, right? Okay. There seems to be another seam here. That's kind of interesting. Oh, I see. Interesting. just to get rid of that. Here we go. So again, I've made a curve here, and I'll probably make a curve somewhere up here. Let's do that. Again, I'm just extracting an ISO curve. And then if I have my not turned on, option turned on for object snap, I can actually snap to where there's a knot or a sort of already an isoparm. And that way I can sort of selectively trim things and not have like half of an ISO patch showing. So here we go, trim. Just going to select the two curves I just made, hopefully. There it is. Okay, those two. I'm just going to trim this part away for the time being. And now, last but not least, I really needed to sort of, oh, I think I've already split it. Look at that. I'm not sure how I split that already. But if I think about this for a moment, right? Not all of this is going to be curtain wall. I have to sort of, if I'm going to have to break this up into sort of portions that actually are inset and have windows or are, sort of change in materials, right? And change in thicknesses and things like that. Then I'm going to have to break this up and make it, smarter and stuff like that. So I have this already sort of broken. This sort of already is happening, but I'm going to, let's see. I'm going to go ahead and sample some more ISO curves. I'm going to say that from here on down, maybe, we'd have a curtain wall, and then from up here, we'd have something solid. Or something that looks solid, maybe has punched window openings in it later on, if I want to do that. Okay, so I'm going to go ahead and split this. Let's see, split this with that curve. Let's see here. Okay, there we go. So now I have this, I have this, I have this. And maybe it's the same thing down here. Maybe this begins sort of glass facade. So let's see, go ahead and do that. So I just made a curve here along that isoparm, and I'm just going to go ahead and use that. And I'm going to split this surface with this curve that I just made. Yeah. All right. So now I have several different patches. You'll see that there's no surface that intersects itself now, right? So I do have to do a little bit of cleanup and thinking about this, right? Ahead of time. All right, so I'm going to go ahead and save. All right, let's go. Rhino to Revit example. Sure. Save. Sometime today, preferably. Oh no, I went through all of this. What's going on? Save, you dumb piece of garbage. Yeah, no, I accidentally selected it 3 times. Come on. Yep, there we go. All right, finally, saving. I don't know what that was all about. Yeesh. All right, anyway, I have this. Now, there's a couple of other things I'm going to say here. For whatever reason, it seems like I could have the units in Rhino set to feet, and then I can set Imperial units in Revit. Then I bring in this geometry into Revit. It seems like it's in inches, and it's like 1/12 the size. I don't know why. It's so annoying. So that's the other thing I'm going to quickly do here is just scale this. So I'll just scale it around this base point here. And I'll say scale factor of 12. I'm just going to scale it up 12 times. It's so annoying. I don't understand why it's like that. See, this is already set to feet, but it is what it is. I'm going to go ahead and save. And there we go. Now, once I have just the geometry I want to bring into Revit, and it's all prepared to bring into Revit, I can go ahead and close Rhino for the time being. All right. And open up Revit. I'm using Revit 2021, I think, here. It shows these examples with double curvature, but it's not so good with double curvature. unless you really know what you're doing here in Revit. Maybe that's a project for me over the summer, is to figure out how to really sort of get under the hood of Revit here and make it do what I want it to do instead of, Revit should work for me and not the other way around. I mean, just, I feel that way about Rhino too half the time. All right, here we go. Okay, so this is going to open up. I think by default, it's just going to show me like a menu. Do you want to open a file? Do you want to create a new file? I'm just going to say create new. By default, what comes up is Imperial Units construction template. I'm just going to leave it there. And you leave the construction template. That was my default. I'm just going to leave it there. It'll be really easy to find the Axon sort of 3D view in the construction template for whatever reason. Imperial meaning the units used, so feet and inches versus metric, right? So I'm going to hit OK. There we go. And it's just starting up a new file. You'll see a bunch of tabs along here: architecture, structure, steel, blah, 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 modify. That's an important one. Then you'll see a set of menus and properties over here, as well as what's called the project browser. I'm just going to go right now. I think we're in, I don't know, top view or something. I'm just going to go to 3D. I'm just going to double click on the 3D. You'll see that I'm in an Axon. You'll see that there's, sort of hypothetical floor layouts, elevation tags. I'm not going to be so concerned about those. I've gotten this far. I've just basically created a new file and I've set up the view. So I'm going to go to the architecture tab. I'm going to go to component. I'm going to say model in place, right? So normally if I was going to create something new, this is what I would do. When I say model in place, it's going to give me any number of different sort of family categories I can look at. Since I'm bringing in geometry, surface geometry from a different file or a different CAD program, I'm going to pick generic model. I'm going to hit OK. It's going to say, well, would you like to name it generic models 1? I'm be like, yeah, whatever, I don't care. Okay. Sure, Revit, name it whatever you want. Bruh, come on. All right. And so now I get this sort of create tab. I'm not going to hit this finish model yet, because what I need to do is I need to, make this component. And instead of creating something from scratch in Revit, I'm going to go to the Insert tab up here. I'm going to say Import from CAD. Okay, there it is. And now I can look at the file types that can be imported. DWG, not a big surprise. That's an AutoCAD file. DXF is another Autodesk file exchange. DGN is from MicroStation. We have SAT, which is a sort of it's a file type that preserves a lot of different geometry types, but it's kind of generic. It's not specific to a brand. SketchUp files, if you're fancy like doing stuff in SketchUp and bringing it into Revit, you can import those in natively. Same with Rhino. So there, I'm going to pick 3DM, and let's just go to my desktop here. I think is where I was saving this, I hope. And it's this one right here, saved at 130. There we are. Okay, didn't give me any errors, so that's always bonus. What I'm going to do is I'm just going to rotate this around. I don't have the right kind of mouse apparently for Autodesk. I'm using the Apple mouse. So I really, again, it shouldn't be so hard to like navigate your way around the screen in Revit, but it defies all logic to me. There's no muscle memory in my body when it comes to sort of clicking and dragging around the screen here. There we go. I think I'm holding down Shift and using my right mouse button. Okay, so you can see that I have a number of different sorts of geometries. I'm just going to turn it the way we were looking at it in Rhino before. Maybe over here I'll say zoom all to fit. Let's just get it all centered up there. All right. This looks like it's loaded in correctly, so I'm going to just go ahead and now hit finish model. That's really important. It's easy to forget. And so I'm going to go ahead and just save the Revit file. I'll call this junkie delete me later. Not can make delete me later. That way I know what it is. Okie dokie. And so if you'll remember, I mentioned several things. One is that I was going to add glazing to this crisscross portion. It's sort of crisscrossing here in section. And then I was going to, make this into a sort of thicker shell, and then see if I could articulate it into, something more architectural. Thinking about paneling or giving it some reveals or something like that, to break up what a really sort of large piece of geometry and just sort of break up the scale and give it a little more of a sense of architectural geometry and material seams and joints. So first things first, let's look at curtain systems. I'm in the architectural tab. You'll see that we'll be using wall. In fact, we can make walls from faces of surfaces that we brought in. We'll do that in a minute. There's that component button again. I'm gonna go to curtain system, curtain wall system. It's gonna bring up, I think by default, a 5 foot by 10 foot curtain wall system, at least on my machine. Okay, so when I click that button, the curtain system, it's gonna bring up the properties box for the curtain wall system. And usually in here, I can start to search for different sort of curtain wall systems. I can edit it. I can duplicate it and make my own if I wanted to make a custom one. You can see that there's a number of parameters here I can begin to adjust, like the spacing in the one direction versus the other direction, 10 feet by 5 feet, right? Is it a fixed distance? You can also say a fixed number or maximum minimum spacing. And then also the types of mullions, right? So I'm just gonna say okay for the time being. And I'm gonna say create system. We'll go back to that properties box in a minute. Create system, select multiple. I'm just gonna go ahead and select this. Let's just look at it. See, it turned blue. I'm gonna say create system. All right, I'm just gonna try to zoom in here ever so carefully. You can see that it actually created sort of 5 by 10 glazing, right? So I sort of have these quad panels, like it took that doubly curved surface and basically made it into a set of quad planar glass panels. I can always go back and say edit type. Doesn't have any mullions. I can go to like grid 1 mullions and I can start to change what kind. Let's say rectangular mullion 1. Sure. Rectangular mullion 1. Let's go ahead and apply and then hit OK. We'll take a second and I'll populate this hopefully with some rectangular mullions. Aha, in fact, there they are. Like a mouse. All right, mouse dog. Edit type, and again, I can go back in here and start to change things around. Border 1, border 2, etc. Let's see what those are. Oh, okay, all right. I'm gonna go with quad corner. Let's see if that actually changes anything. Maybe it cleans some things up or not. Oh, never mind. I'm just gonna undo that. Just turn those off. None. None. Anyway, I'm just playing around with the curtain wall system till I get something I like. What? Huh? Not sure. Curtain panel. Oh, glazed, sure. Fixed distance 10, 5. Again, with fixed distance, you'll notice that if we get to an end and we have like 2 inches of leftover space, it'll look kind of funky, but I'm just going to, or we could do a fixed number, right? We could do like the number we want to cross. Yeah, I'm just gonna hit apply and hit OK one more time. See if we get something out that looks okay. Hopefully we do. All right. Let's see, we have the system. I'm not going to worry about room bounding and things like that. I'm going to say select multiple. I'll go ahead and select this one. Why not? Create system. Let's just do it. I think we can all appreciate when it happens at a click of a button, even if we have to wait a couple of seconds for the blue wheel to keep spinning. 75. There we go, right? All right, curtain wall. You can see it did some stuff here. Oh, well, maybe you can see. Actually, no, we can't see. Come on, there we go. It's actually kind of hard to see, ironically. We have a seam here that we probably need to clean up in Rhino. Maybe there's a mullion going that direction, but if so, what a fortunate coincidence. I'll do it one more time. Select and yeah, I just selected it. Come on. Yeah, create. Okay. So there's some curtain wall. Let's say the other thing I might do is, again, I can take faces and surfaces and I can convert them into wall geometry. I'll try it here. I'll go to wall and I'll say, instead of, if I do wall architectural, then it'll give me options for like drawing and plan, or, wall, the sort of the shape of a wall. And then I can articulate, other parameters like the kind of wall it would be. If we're talking about typical wood stud, 16-inch on center with, blah, 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 versus metal stud with air gap and masonry hung on top, or whatever it is, right? More than you ever wanted to shake a stick at, sort of designed by pull down menu. But I'm just going to say wall by face, and then I'm just going to select this face. And then I can pick the type of wall, and I'll just say generic 12-inch wall. I'm just going to undo making that a wall. There we go. I can change this to 12, and then I'll say, okay, wall by face. Select this again, it'll get a little thicker, right? So that basically takes a sort of paper thin surface and thickens it up into a sort of a wall system. And I made it generic so that it wouldn't be like, anything in particular here, Now, the key thing here is that, again, gosh, I really want to be able to do wall reveals. It really burns me that I can't. Because all it is, I mean, it should be the easiest thing to do. But for whatever reason, I don't know what it is, but they're just like, you don't need wall reveals and curved walls. Like, the hell we don't. Anyway, so I couldn't get that to work, because that's a really easy, nice way, particularly, when you start to space these things out by, let's say, dimension, you could make this start to look like it's a, let's say, clad in aluminum panels or something like that. And again, I'll show you how you could do that potentially in Grasshopper instead, if that's an issue for you. But anyway, I just wanted to sort of go through that. Here we have curtain wall. We do have other mullions. You can, if you start with, like I say, a curtain grid, and then you want to actually specifically add mullions at different places along that grid. But the curtain system is really nice because it takes advantage of that repetition, particularly economy of scale. Just does it for you, which is really kind of a nice thing to do. So let's say at this point, I'm ready to bring this back into Rhino. I've done what I can in Revit. I'm going to have some floor slabs in Rhino that I'm going to add to this. I'm going to, cut out some holes in here and make some windows and, whatever. And so maybe I'm ready to do that. Let me go ahead and save the Revit file so I can always open this back up in Revit and re-export or change something, right? I can always go back in and change the parameters of this curtain wall system, for instance, right? If I need to. But now I'm going to go to File, Export, Cad Formats. Okay. And I'm actually going to pick DWG. All right, so export CAD formats DWG. What's really nice is that these days they've made DWGs a little better. So again, this is to export the geometry back into Rhino. I'm going to export as a DWG. And it's going to pop up with a box, DWG export box. It's going to show me, okay, are you sure this is what you want to bring in? Yeah. So I'm just going to hit these settings, this dot, dot, dot. And it'll bring up a box with layers, lines, patterns, these sort of tabs along the here. And what I want to do is I want to be very careful. And I'm going to say, I want to preserve solids as solids rather than converting them into polymeshes. Used to be back in the old days, DWGs would just turn everything into polymeshes. Now there's an SCSI solids option, which is good. So I'm just
Hey
going to
Josh,
turn this into solids. Yeah.
I typed something in the chat.
Okay. Where's the chat? Come on, there it is.
Can you do that with the grid, perhaps?
I'm sorry, what now?
Because you were talking about.
Wall reveals?
Mm-hmm. Can you do that with the grid, or would you have to draw
Oh, you mean
each
with the
of
curtain
those?
wall grid?
Yeah, would you have to draw
Yeah,
those
you might be
individually?
able to. Again, I mean, if you, particularly if you, it depends, right? Like you can always try to find a manufacturer that's made a custom Revit family too.
Mm-hmm.
Let's say of, let's say Conair or something, looking at panel facade systems or something like that. But I'm just gonna not deal with it right now.
Okay. No
Anyway, I'm just
problem.
gonna export this out as solids. That's really important. You want to make sure that these are preserved as solids. What that does is it preserves things as poly surfaces. And they're not a bunch of unwieldy meshes. I'm gonna go ahead and hit OK and then hit next. And I'm just gonna leave this as default, AutoCAD 2018, DWG, whatever. And I'll say, I am dead inside after trying to make wall reveals and curved walls in Revit. I do feel dead inside. And hit OK. So I just saved the DWG out. I'm exporting the DWG of this out, making sure that everything's preserved as SCSI solids. And that's what I'm going to import back into Rhino. So as soon as that's done, I'm going to go ahead and I think it's safe for me to close out Revit at this point. I'm going to import it back into the file that I exported out to Revit so that we can compare what we took from Rhino into Revit and what we're getting back out from Revit and putting back into Rhino here. Just go ahead and open that up. And I'll show you the import process, which is actually quite easy. The only crappy part is that it'll be scaled. It'll still be 12 times as big, and we'll just scale it down. Again, 1/12. It's really kind of crazy how that worked out. I don't understand it at all, but I'm not sure what the deal is with. Let me just sell all curves here and delete those. All right, so now that I have this open, I'm going to say File, Import, Import, File, Import. So we can import, let's say, something else. I am dead inside a DWG. Okay, good. Say that 5 times fast. I'm just going to, wow, I think I'm just going to leave this as the default. Yeah, and hit OK. Like I said, I'll probably just have to scale this back down to 1/12. Again, I do not understand why. It defies logic to me. Why the unit scale factors just don't match up going from Rhino to Revit. I suspect it's not the case if I was doing a DWG from AutoCAD. So it must be a Rhino thing. Rhino 7 scale and units, when I bring things in and out of other things, just doesn't work so well. I don't understand how they broke that. It seemed to be one of the things Rhino was good at back in the day. All right, so we're just waiting for this to import in. It's about 5 megabytes of lots of solids and poly surfaces for each of those mullions, which are basically just boxes. That's essentially how Revit does this stuff. Yeah, here we go. You can see that's much too large. So I'm just going to go ahead and type in scale right now, scale. And I'll just make the base point over here because I wanted this to be a little farther away from where I started so we can compare. I'll use my scale factor 1/12, right? So 1/12 of the size, quite literally right the fraction. You can see there it is. Oh yeah. in all its glory. All right, so let's talk about what we got out of this. First of all, we got out those annoying elevation tags, which are right here, floor levels. I'm just going to select all the objects in that layer and delete, because they're just kind of dumb curves at the moment anyway. And let's see what we have here. Oh, yeah. I don't know why they picked these putrid layer colors. I mean, they're truly awful. I don't get it. There, that's better. You're like, what makes that a good color for me? I don't know. I just like it. There's, let's see, glazing. Let's change the color of that. To orange, of course. There we are. All right. I'm actually just going to turn this off. That's the wall we created, right? Yeah. Sort of thickened stuff. You can see here we have pretty much everything that we brought in from AutoCAD, or from Revit, sorry. Yeah. This one looks a little cleaner than the one before. It's still a little goofy, but again, there are ways to clean that up if you're really interested in doing non-conventional things in Revit. It's actually a pretty powerful tool. It's just not so easy to get under the hood with things there. There was the original geometry that we fed in. It's still there as a set of surfaces. Yeah. Okay. All right. So that's basically, I can go back and forth between Revit and Rhino if you need to. What I recommend is, if you're working primarily in Rhino, take only the stuff that you need to bring into Revit, and export it out as its own file, import it, open it in Revit, or sorry, I guess it's insert from CAD into a generic model, right? And then do what you need to do, and then you can export it back out as DWG and bring it back into Rhino, put it into place, make sure it's the right scale and everything. Right. When it comes to the other way, again, what you're doing is you're primarily, let's say you're working primarily in Revit, you're not going to be able to generate a lot of this stuff in Revit. So you're probably going to take this into Revit and try to make sense of it. And essentially you'll be, you just want to make sure that you're avoiding any self-intersections. If any of the geometry is actually self-intersecting, then they'll pop up with an error. They'll say cannot bring in the information. And it'll give you like an error number, probably number 1 or something. Okay, so that's why I broke things up and did some splitting and trimming ahead of time. Okay. So now I'm ready to reinsert my floor plates in here and start to add maybe, some furniture and show some stuff like that. I would say that there are also some easier ways of doing some of this stuff. And sometimes, people find it easier to do something in Revit or Rhino or Grasshopper. I'm not here to judge. I'm just here to show you sort of all the different paths, or lots of different paths, and you can sort of experiment and find the one that works best for you. So I'm going to go back to this original, and I'm going to make a copy of it over here. And we'll use that, and we'll do something interesting with it here. Just a moment. Let's see. What I'll do is I'll make another layer here, and I'll call this original geometry. I'll select that, and I'll put that on this new layer I made called original geometry. I'll even go back in and fix the typo I put in the file name or the layer name. I'll make that the active layer. I'll turn this old one off. See, I'm always want to make sure either in the same file on a different layer that I can lock and turn off, or in another file, I want to make sure I have this original geometry still, just in case. I don't want to do something potentially destructive and then not be able to go backwards if I need to. Right? So now I'm going to go through a couple of workflows that you can use in Grasshopper. Let's see. Depending on what you're trying to do, really, I mean, it all depends. There we are. Recent files. Let's see. Curtain wall, paneling, and then wall reveals. And wall reveals is the one I just could not get to work. Oh, it really drives me up a wall. Just not my day for putting in nice crisp wall reveals to for shadows, and I just darn it. Anyway, curtain wall. Let's start with curtain wall. Okay, so I'll just go through this step by step, but this was stupidly easy for whatever reason for me. What I did is I bring in a surface, I carve it up, and I did a million different ways. I populate it not only with points, but then I find the normals at each of those points, right? And I take those normals and I start to loft them together as lines along the facade in order to create basically a paper thin mullion. And then I can, oh, did I not save? Oh, and then I can just bake those. I can offset them into thickened mullions back into Rhino. Yeah. All right. So that's basically what this is. And at certain point, I get like a data tree out, like here are all the normal lines going along in like this sort of longitude, right? And so each longitude line or each longitude isoparm or mullion is its own sort of branch. So then I have to do it I have to flip the matrix and turn longitude and latitude and do it in the opposite direction as well. All right, so let me just show you how this works. New document. Now, here's the interesting thing, right? Did you notice that Revit turned all the glass panels, all the rectangles, all the quads, turned this doubly curved surface into a set of planar quads. And we're going to do the same thing in Rhino before we even start. So if I know that I want to take this and make it into a curtain wall, I can essentially rebuild it here in Rhino. I'm going to do that right now. I could do that in Grasshopper, but it's actually just easier to do it in Rhino right now. So I'm just going to do that right now. Here, I'm going to select this. And the command I used was rebuild. Okay, rebuild. And so what it's going to do is it's going to bring up a box, rebuild surface box. It's going to tell me the current count point in U and V, right? So the number of isoparms, the number of longitude lines and latitude lines, and then also the degree of curvature, right? Typical surface that you're using in Rhino is third degree surface. If it's planar, then it's usually a first degree surface. So first and foremost, I'm just going to do this, right? I'll just keep these parameters the same. I'm just going to say preview. I'm going to hit OK. When I rebuild the surface, look what it does. It brings back the entire surface that I trimmed from, which is not good, right? So what's interesting about this is that the way Rhino works is it's a NURB surface modeler. And so NURB surfaces are stored as quadratic equations in the actual file itself, okay? So when you trim a NURB surface, it still remembers that larger surface, and then it remembers that you trimmed it, and then trims it out every time you open up that file, right? So every time you want to do something to that trimmed patch of a surface, it's going to do it to the entire surface because it remembers that entire surface. So what we're going to do is I just quickly show you some quick, easy, painless ways to rebuild this, right? And again, it's all about file management and I think also layer management in order to do that. I'm going to go ahead and make this one. I'm going to call this wireframe. Okay. And I'm just going to take this and again, I'm going to go to the curves from objects tool palette. And I can do things like duplicate the border of this. I can extract the wireframe, right? I'll just do extract wireframe. And I'll go ahead and delete that original surface. Now what you'll see is that I have all of those curves that were the isoparms. They're now curves, right? And I deleted the surface away. So now I just have those curves. I'm just going to undo that. I'm just going to make the wireframe layer the active layer before I make the wireframe. There we go. All right, now I can delete that surface away and I can turn all the other surfaces off for a moment. Just look at the wireframe, right? So now quickly I can rebuild this. I'm gonna go to my surface creation tools. What I can do in this case, probably I have a rail here at the bottom and a rail here at the top, and then a couple of cross-section curves. That'll give me something super duper close to the original surface that I had. And I won't lose much fidelity there. So if I do it this, so say select first rail, second rail, all the cross-section curves. Bam, there we are. Go ahead and delete that wireframe. I just selected all the curves again, deleted those away. Right, you can see that it's not really missing a beat here. That seam is pretty good. Now I can go ahead and rebuild this. So I say rebuild. Yeah, why not? Let's rebuild it. Now when I hit preview, look at that. I'm rebuilding at 40, 41 in one direction versus the other. That seems pretty extreme. So I will do instead, let's see, 24 and 12. Let's see what we have here. Preview. It looks okay. Now instead of making 5 by 10 foot panels, I'm telling it to divide a certain number of times in each direction, right? Which was one of the options in Revit. If let's say we're making a custom curtain wall and each panel is potentially different. Now, let's span control. Let me just up this a bit. Yeah, that looks a little better. Maybe, well, maybe I had it better before. Who knows? Let's see. Let's go with 36 and 18, something like that, like a 2-to-1 ratio here. Preview. It doesn't look so bad. I'm going to hit OK. All right, now we have a fairly clean surface. Now I'm going to go ahead and do rebuild one more time. Okay. But the other thing I want to control here is the degree of curvature. I'm going to turn the degree to 1 and 1 in both directions. Now I'm going to hit OK. Now what that does is it converts this into a sort of quad faceted surface, right? I'll do it here just so you can see, so you believe me. When I convert this to a first degree surface, do you see how it becomes triangulated? All right, so anyway, I'll do the same thing here with this one, but with different parameters. Of course, I have to rebuild it first, or sorry, remake the surface. Let's see here. So first things first, wireframe is the active layer. I'm going to make one more layer. I'm going to call this rebuilt. And I'll put this rebuilt thing on the rebuilt layer here. That way I can keep using my wireframe layer to make wireframes. Dun, 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 dun. Nope. Wireframe on, rebuild off. There we go. Okay, so again, I'm going to extract wireframe. Turn off the original geometry for a moment. There we go. I'm going to go ahead and do a similar pass here. I'm going to make a new, let's see, surface. Here we go. Sweep with 2 rails, sweep along 2 rails. That usually does a pretty good job here. Let's see, I'll do the top and the bottom, and then I'll give it these cross-section curves here. Why not? Make sure to put them in the right order. Okay, so now that it's its own original surface again. That's always helpful. I'll turn this back on. Turn that off. I'll go ahead and delete this away. Turn this back on. There we are. All about layer management here at this point. Rebuild. Go ahead and rebuild the surface similar to the other one. Let's see here. I'm actually going to turn that layer on and try to get a similar density here. Let's see. 18 looks about right, but then this needs to get much larger. Let's go with like 72 maybe. Hit preview. Oh, that's not the right direction at all. All right. All right. Anyway, double that. Let's see what happens here. Let's increase it a little bit. That's much better. Okay. All right. And again, you can see, hopefully you can see that this is actually a faceted surface. Here, let me recenter my, there we go, recenter myself here. So I don't know if you can see, but there's like actually like a seam there, right? It's not smooth. All right. I'll go ahead and just delete this part away for the sake of doing this more quickly. All right, so again, I'm just rebuilding. First of all, I'm rebuilding the surface, like recreating the surface, then I'm rebuilding it with specific parameters to generate the sort of spacing, and also turning down the degree of curvature from a 3rd degree curve to a 1st degree class curvature, which turns it into a set of faceted quads. This is still one surface, by the way. Now I can bring this into Grasshopper. Okay, I'll make a surface widget, set one surface. I'll just sort of show you how I got this. There it is. All right. This should be in the rebuilt layer, just making sure. I'll turn these layers off for the time being. We'll just look at this in Grasshopper. Yeah. I have to remind myself what we're doing. Oh yeah, we're dividing the surface, and then we're evaluating at each of these UVs. And then we're taking those normals, making lines, and we're lofting those together. That was such a nice, elegant way of doing it. I'm so smart. Anyway, you're like, yeah, eye rolls. All right, divide surface. Yeah, why not? All right. Of course, we're going to need a surface. We're going to need a number of divisions, and the number of divisions is going to be some sort of slider. Constrain that to integers. Start with 1, since we don't want to divide by 0 ever, because mathematically it just doesn't work. And I'll give it something totally silly like 100 as the max. And I'll copy and paste that. Now we'll split this surface in number of times in U, in number of times in V. And of course, we'll change that. So what were we doing? 16 by 48 or something, maybe? Could be. Here. So I'm turn on my rebuild version. And that, of course, is not correct. Maybe it was 18. What was it? 36. And then what was I going in this direction? I can't remember the parameters I used, which is like such a bush league mistake. I should know better than that. I can't remember the rebuild parameters I used. Oh no. Anybody remember that offhand? Okay, the answer to that is no. Really? Really? Nobody remembers? Just hanging me out to dry. It's so sad. Sad for me. Okay, well, it's less than 60. Crickets, I know. Throw me a bone here. 48. I swear it was 36 and 48. Huh. Interesting. Well, we'll try that, but we'll see one way or the other, huh? Should have written those down. Silly me. But another thing I'm going to do, so I have those UV coordinates for each of those points, which is really handy. I'm now going to evaluate the surface at each of these UV coordinates. It gives me more information than I ever wanted or cared about. Normals, yes. Normal, normal, normal. So let's see. There's a normal. I'm going to take those normals and make lines out of them. So each of these normals will be a direction. And each of these points will be the start points. And we'll give it a length. There we go. Here we go. Oh yeah, look at that. Maybe I want to go this opposite direction now. So I'll add a -1 as the minimum. Yeah, there we go. We'll go in that direction. Anyway, so these are organized basically in rows, 49 of them going in this direction, and another 49 in that direction, another 49 in that direction. So let's see what happens when I loft these bad boys together. Help if I went to the surface tools to loft something into a surface. There we go, loft. Oh, sorry, they were in columns actually. Now, if I want to get them in rows, I can take the data tree and transpose it. So columns become rows and rows become columns. So I go to sets, transpose, flip the matrix. I guess it's called transpose in Excel. In Grasshopper, it's called flip matrix. Look at that. All right. So what to do with this? We need to bake these into Rhino, right? Baked mullions. Not to be confused with baked muffins, which sound delicious right now. Get me some freshly baked mullions. Not wait. Dig in. Baked mullions. Bam. All right. So I'll include that Grasshopper file for you guys. I'll upload it to Canvas. Of course, this isn't quite done yet. What we need to do is offset each of these. Offset, distance, both sides, yes. No, wait, what happened? Oh, sorry, this is curves. Offset surf, there we go. I was like, where's the solid? No. All right, go ahead and select all of these at once. All right, distance, solid is set to yes, both sides, I'm gonna say yes, so offset to both sides. Let's say these are 2-inch mullions, so I'm gonna, since I'm offsetting both sides, my distance will be 1 inch, right, which will turn out to be 0.0833333 repeated. And it doesn't matter which direction is the normal because I'm offsetting off both sides. There we go. Now I have thickened solid mullions to go with my glazing. Dun, dun, dun. All right. So that's essentially what we're doing here. Right? I don't remember what the number was here. 1, 2, 3, 4, 5, 6, 7, 8. I mean, that's the one thing when I rebuild these, I should have written down the parameters I used. 1, 2. Actually, I guess I can do that by simply doing a rebuild and looking at the starting parameters here. Looks like it's 36 by 18. All right, 36 by 18. So I'll go into Grasshopper and I'll select a different surface, this one. I'll make sure that this is set to 36 by 18. There's just this one I have to change. I don't know, let's see. All right. Works for me. I'll bake these in. Get me some more baked mullions. All right. Go ahead and minimize that. Yay. So let's see. Cell the last. Select the last. And let's offset. Surface these bad boys. Solid, yes. Both sides, yes. Distance, yep. All right. I guess I have to do the same thing here, but you can see where this is going, right? Let's see. Original geometry. There we are. Let's say I'm also going to, the other thing I was going to do is show you the panelization tools. You can do this yourselves in Grasshopper pretty hands-on if you want to be. But I was going to show you a couple of tools that are in Lunchbox Tools that'll help you with this. So when I do that now, what I'm going to do first is I'm going to offset this. So I'll do an offset surface here. Sort of turn this into a shell, essentially. Select surfaces or poly surfaces to offset. That one looks like a good one. Distance will be different. Solid, yes. Both sides, yes. Distance. In this case, I'm going to pick, this is going to be a nice thickened thing. I'm going to go with 18 inches both sides. So it'll be 36 inches total here. Just we'll go extreme. Give this some thickness. There we go. All right, there's the shell. I'll go ahead and make a new layer for it. Call this shell geometry. Shell geo. Turn off that original geometry. There we are. Yay. All right, shell. Oh, you know what? I don't need to do that. Here's the problem, right? If I offset this and then I start to do something with it, it's going to remember that entire surface again, right? So I need to rebuild this as well. Oh, rats. All right, so I'm going to go ahead and turn off the baked mullions. Turn on that wireframe layer, make that the active layer. I'm just going to rebuild this really quickly. So I'm going to go ahead and extract wireframe from it as well. Extract wireframe. La 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 la. Turn off that original geometry. There we are. Oh, Grasshopper's still on. Turn that off for time being so that disappears. Okie doke. Here we have some curves. We sure do. Look at that. More curves than we can shake a stick at. I'm going to go ahead and delete these curves. I'm done with them. Yep. Delete. 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 Oh, look at that. It's gorgeous. It's incredible. I'll never get better than that. So I'm going to go ahead and turn it into a surface with the sweep. 2 rails. There we are. That one and that one. Oh, apparently I have 2 curves here. That's not going to do. All right. There we go. Take 2. Sweep along 2 rails. First rail, second rail, cross-section curves in order. Ta-da! Okay. Not a big surprise there. A little cleaner now. I'm going to select those curves from the wireframe, get rid of them. All right. So there we are. All right. I need to offset this and turn it into a shell, don't I? Yep, I sure do. Now I'll call this, let's say, shell geo. There we are. And yeah, I'll turn it to that layer. Now I'll go ahead and offset surface. There we go. Offset surface. Boom. Distance 1.5. Solid, yes. Both sides, yes. All right. Excellent. Makes me so happy. Baked mullions on. Rebuilt glazing on. All right. So let's turn some of this different colors so we can sort of see a little better. Oh, come on. Really? We call this glass. Mullions. Shell. All right. All right, so let's do something with this shell. I'll open up Grasshopper again. Ah, there we go, Grasshopper. There, it's right there. Come on now. Seriously. Ugh. Really? Could you be more obnoxious? There we are. Okay. Ugh, I thought Revit was bad. Damn. Forgotten how bad Grasshopper is sometimes. All right, so panelization. First of all, when I'm referring to Lunchbox Tools, I'm referring to a plugin for Grasshopper called Lunchbox Tools. So if you go to it, and I'll include a link to it here in a moment, but basically it brings up the Lunchbox tab as one of the tabs in Grasshopper. And being able to sort of turn large geometry, like large surface, into a bunch of smaller ones. Here, like it already has some preset ones. You can do digrid, hexagonal quads, random quads, skewed quads, staggered quads, triangulated in various fashion here, etc. Right? Digrids, quad grids, you name it, they got it. Yeah. Now, what's interesting here is that I'm dealing with a sort of thickened surface, right? So this is actually a poly surface with a face that's on the outside and a face on the inside, and then all these side faces to sort of close it up into a closed poly surface, right? And so I made something that actually takes that into consideration here. If I open up the paneling tools, first of all, we start off with a B-rep, which is the fancy word for saying poly surface, right? And then what I do is I explode it and find all 1, 2, 3, 4, 5, 6 of its faces. Then I do each face one at a time and tell it how many times to divide with whichever panels widget I want. And I can just bake those panels in, pop them in the oven, and bake them back into Rhino. All right, so let's try that. Let's say set 1 B-rep, and I'll go ahead and select this poly surface. All right, so what we do is we have a closed poly surface. And what we do is we explode it and we get the faces of the poly surface, right? So we get 6 surfaces, 6 untrimmed, right? Here's the faces of the B-rep. And I'm just going to pull one of them off each time, right? One at a time. So I'm just going to pull the first item from that list by setting the integer to 0. Let's do that. I'll go ahead and select this. Turn this on. You can see, looks like it's that inside face. It's the first one here. See how it's green? Yeah. All right. Now what I'm doing is I'm just sort of telling it how many times to divide in each direction in order to sort of turn this into a set of, in this case, a digrid panel. Where it's sort of skewed. Was it called skewed quad or something? Yeah, skewed quads, of course. All right. So that's what that looks like. You can see they wrap all the way around the inside there. There's the shell geometry layer. I'm going to make a quad panel, freshly baked quad panels. I can almost smell them. There we are. I'll make it red. Why not? All right, so here we have panels. It also separates the edge panels, the ones that are just triangles, into the sort of B panels. So we're gonna have to bake both of these, right? Bake the ones that are full quads, and then the ones that are at the edges that are only half triangles, half quads, triangles. Fresh baked quad panels. There we are. Always remember that. Fresh baked, I'll be like, what the hell was I thinking? Must have been hungry that day. Okay, there we are. All right, now 24 and 24. I'm going to jot that down this time, be a little smarter, and actually write that down. 24 and 24. I'm going to go ahead and change which surface of the poly surface, which face of the poly surface we're going to do now. Let me set this integer to, instead of the first item with an index of 0, the second item with an index of 1. That looks like it'll be the outside face. Well, that's fitting. And you know what? I'm just going to leave that the exact same thing, 24 by 24. I'll go ahead and pop those panels in the oven, bake them away. There we are. Let's give those other panels some friends. There we are. This is Feel Good Friday, right? Oh yeah, I think we all feel good on Fridays. Okay, so I'll change the integer button or integer number again. This time the index to 2, and we'll get it. The third item will be one of these edge surfaces here. It'll be ridiculously densely populated here. I'll show you, but it's really important that, you know, these things would wrap around, right? So I just want to sort of show, where are they? No. Maybe I should actually, like, hold on, select these. Untrimmed 552. Dang, that's a lot. Just try to highlight them green. Oh, it's along the bottom surface there. Here, sorry. This isn't rotating very nicely, is it? Okay. So I really only want 1 bay along here instead of 24 bays and 24 bays. So I went 24 bays in this direction, but only 1 bay in that direction. So now I just got to figure out which one of these I change to 1. It's that one. Oh, look, yeah. See, still matches up with these seams across, both on the outside and the inside, right? But it's only 1 bay going in that's really shallow direction. Yay! Now it's telling me that there are no panel A panels, just B panels, just triangles. So go ahead and bake those in. Oh yeah, add them here. You know, after you bake them, you got to cool them down before you pop them in your mouth. There we go. All right. Now I'll go back and change this index. I want the 4th item, so an index of 3. There we go. Just going to go around and do these, each one step by step. Going to look for the green highlights here. Let's see if I zoom out just a bit. Pan down. Looks like it might be this edge over here. Let me just turn it and find out. It sure is. Look at that. Oh yeah, that is a good looking set of triangles too. I do say so myself. Maybe. Is that in the right direction? I think it's got to be. All right, so I'll go ahead and, or maybe not. Maybe I need to change this to 24 and the other one. Let me just double check that. No, clearly that's not correct. Okay, I'm overthinking this. I'll just bake this in. All right, and so I'm just going around and doing those edges. Oh, what? No, don't bake. Sorry. Cancel. Right click. Come on now. Go down to the 5th object, the 5th edge. So I'll have an index of 4. That'll probably be up here at the top, maybe. I'm just going to guess. And I guess correct. Look at that. All right. Bakey McBake. Let's make it by bake it. Last but not least, the final edge. Da, 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 dun, 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 dun. There it is. Yep, excellent. All right, so I'll bake this as well. And let's see what we have here after I turn off Grasshopper. All right. Right, so there's the skewed quad shell now, sort of converted into a set of panels, right? Oh, that red is so saturated, it makes my teeth hurt just looking at it. Just turn down the color saturation a bit here. And let's see. Fit to screen, I'll select this stuff. Let's look at it without the isoparms. Just double check that patterning here, right? So there we are. Yeah. So now you know how Herzog and Demiron do it all the time. They just have Grasshopper and Lunchbox tools. Same thing, if I wanted to do, instead of skewed panels, I wanted to do triangles or, sort of quad panels that line up, make a grid, I could do that, etc. Right? So again, I'll provide you with that file as well. So that's how I went from some strange geometry to some more architectural geometry. No less strange, no doubt, but more architectural. I'm trying to sort of break things down into pieces and trying to sort of figure out how that would work. Class, baked mullions. Select objects. I'll turn off the Isoparms on that. And on this as well, select objects.
So for this, Josh, like, how would you implement, say, like windows or a door, or do you want us to?
So here, let me explain how I would do that, right? So no building, no piece of architecture to just like put in a door right here, right? Like and say like, here's the ground and there's the door, right? So if I was to do that, I would probably have peeled this back, have it in here, the shell. I would walk under here past the rain screen where I see all the structure holding this onto the skin. And then I would integrate it into my curtain wall, right? Like, part of these curtain wall panels would just be like doors, right? And typically that's how you would see it, right? Does that make a little more sense? So if I wanted to actually punch openings out, then of course I could do that. I would take some shapes and punch them out, in this. Then, I basically inset some glass on the inside here. So if you think about this as being the sort of the opening that you have, you could easily situate a plane inside of here, even with a frame, a small frame around it like that, right? I might have some floor slabs popping in here, pulled back, right? I'd probably need to show some railing and stuff in here and start to add people and furniture. Right? Whereas out here, if this is outdoors, maybe I'm having some trees and stuff. Right? I mean, this is Photoshop, trees, people. But yeah, I mean, typically, no building's going to be like, here's this crazy geometry, right? And then here's a door, right? There's the door handle. No, I mean, like normally you would pull this up, right? So, let's say this is panelized. Right? You would see glass back behind this, right? You would see that curtain wall, right? You would see that this one happens to be a double door or something, right? And that's typically how it looks in elevation. If you're having problems reconciling that three-dimensionally, just quickly sketch out an elevation, show me what you're thinking. And we'll figure that out, right? I mean, what's nice about that, is that if this is, let's say, the public realm, and so this is sidewalk and, here's street out here, right? I can have a chance, again, another place to put some trees, right? Start to, here's a double-decker tree, right? It just has a couple of branches on it. People can actually pass underneath this sort of really large sort of shell canopy, right? Stores can have a presence out here, You know, how you put a door in this geometry, that's a good question. Beats me, right? But mostly, I mean, that's what you would do. You would sort of end this here and then maybe push back with a soffit and put some glass along this, right? Make it deeply inset. I mean, just look at like the built environment around us, you know, especially urban areas. It's, you know, that street scale, their buildings are usually quite porous, right? You can see inside of them, right? They're made so that if you want people to come in and buy stuff, they can. You know, and so, you know, the facade usually at the street level is usually different than the facade that projects outwards in the second, third, fourth, ninth levels, right? I mean, that's just a pattern you see everywhere. And so, you know, there's a lot of different ways to do that. But my suggestion to you is look around for how to do that stuff. I mean, you know, architecturally speaking, we're not reinventing the wheel here. You know, things work in cities, right? And so, you know, that's what I would do is look at cities to see how they work. But you know, essentially, that's more or less what I'm thinking here is, you know, let's say this was an entrance, right? You know, what I would do first and foremost is figure out where this thing stops, how to pull back a soffit somehow, you know, put some glass in here as well. Now suddenly I have this sort of really interesting pathway for people to walk through in this incredibly large atrium. You know, and there's going to be some doors and, you know, that swing open, you know, in this curtain wall that's sort of set back. Okay. Similarly, if it wasn't the whole facade, you could potentially punch an opening, right? And then again, sort of bring an architectural entrance into this thing, right? And in places where there's, you know, weather is actually a consideration. I mean, we don't have a lot of weather. Usually you have double doors, you know, airlocks and things like that. But somehow, for some reason, we get away without having to do that here, even though it'd probably increase the efficiency of our air conditioning systems or cooling systems if we did. All right. So, I mean, that's another way of looking at it, right? Oops, let me turn the annotate tools off for just a moment. There we go. Try to spin this around. Come on, Rhino. Ah, here we go. Sorry, I spun it around so many times, it's silly. But let's say, oh, okay, I'm just waiting for this to react now. Oh boy, might be here for a minute.
I mean, if it's not a lot of work, could you actually put a window in there? Can you show us the step of?
Put it in here?
Yeah.
So I'm thinking maybe a la, let's say like Norman Foster in Switzerland. There was that project he did. I'm not a huge Norman Foster fan, but when it comes to like building systems, that guy has it going on. Norman Foster cedar shingle. Let's see. Maybe it's not cedar. There we go. Yeah, Chesa Futura. There we go. Right. So here we have like a large shell with windows cut out of it, right? So in that case, you know, I'm probably looking at, I could do it several different ways, right? It could be a part of the surface geometry, or I could have something that looks like a grid that's been superimposed on top of something that has nothing to do with the grid. So I'll do it several different ways here. I'm gonna go into elevation just for a moment. Let's see what we have here. So let's take a look at this shell for a second. Maybe. Come on, I only have the shell on, so it shouldn't be too hard here. All right. So here's what I'm more or less thinking. What I'd probably start to do is draw a box in elevation, starting to delineate what these openings might look like and, you know, their extents. Oy, okay, it's way back here. All right, that's fair, I guess. I'll go ahead and make those super deep for whatever reason. So let's say I'm going to make a copy of these in a couple of places. Just sort of. Not that I think this is a good way of doing it, but you know, like I wouldn't want them to look like this necessarily. But I'm going to go ahead and move those over here and start to intersect them with this shell. Ortho's on? Yeah, it sure is. Okay, let's turn that off. Oh, Rhino's really like, come on, Rhino. What's going on, Windows? Sometime today, preferably. I mean, I like Friday. I don't want to be doing this all day until it's Saturday. Come on. Should have it better. Should be better. Come on. What's it doing? Oh, so it's Windows, not Rhino. I'll give this. Windows 10 is usually pretty responsive even when Rhino isn't. So this must be a Windows. Yeah, sorry, I'm just waiting. I apologize for it's taking so long. Anyway, what I would do is basically just start trimming things out. Right, you could do a Boolean command potentially if everything's solid and everything is within a certain tolerance to be watertight and sort of manifold. If that's not the case, then you could probably start to do some selective trimming out here and there. Use one to trim the other and then the other to trim the first again. But here, let me just sort of see what's going on here. Ugh, come on, really? The other option is if, you know, if I wanted something that was actually more indicative of the actual geometry of the surface, you know, I could begin to sample isoparms across that outer surface and the inner surface as well, and begin to form sort of like, you know, like the sort of checkerboard pieces, you know, for this sort of skewed warp checkerboard that's already mapped as isoparms on the surface, right? And then use those to sort of cut openings through, right? But you know, one way that was the two ways I was going to show for what it's worth. I'm just trying to fill in the lost time here that, you know, the spinning blue wheel of death is certainly not helping out at the moment. Sort of, oh, there he goes. Hey, oh. Going to move from. All right. No, that should have been an easy. Yeah. Come on, Rhino. Get with it. All right. There we are. So here, let me just see what I have here in perspective view. I mean, I've seen better, but let's say I wanted to put windows in like that, right? So first of all, I'm going to make a copy of this before I do something potentially destructive here and tie up my machine indefinitely as well. I'll save. Maybe it's been a while since I actually saved the file. I wonder if that has anything to do with how much memory it's actually using at any given time if you haven't saved it to the hard drive. In this case, I'm actually kind of inclined, since I know these are solids, to use the Boolean subtract, so Boolean difference. It says select the surface or polysurface to subtract from, there it is. And then to subtract with, so I'll select those, right? Poof. Right, and everything was trimmed out nicely as well. So I still maintain a solid. When I subtract a solid from a solid, I get a solid. From there, you know, maybe it's about, you know, maybe I need to put some glazing in. Let's see here. I can do surface from 2, 3, or 4 edge points and turn my object snaps on and go to mid and find that midpoint and that mid and that mid and that mid. Bam, now I have glazing, right? You know, if I needed to do a frame, I could, you know, find the outline of that glazing now and, you know, make a frame, right? Okay. Let's say for some reason Boolean difference didn't work. You know, I could basically manually do a Boolean difference. I'll do this in perspective really quickly. Hopefully you can see what's going on now. No, really? Sorry, it's just become unresponsive again. All I was going to do is, oh, no. Okay, sorry, there it is. I don't know what's going on here. But what I would do is I would say, I'll use this as a cutting object to trim these boxes one by one. Oh Isn't that satisfying to see, like one by one? I don't know, something about it, just like, Oop, I hit right click by accident. I wasn't done yet. Now I'll use these as cutting tools to cut this. Sure, whichever one, I don't care. Right, either way. Right. Another way of thinking about this is, those are pretty divorced from the actual geometry of, and there's nothing wrong with, say, like having a sort of interplay between the city grid and then this non-grid like geometry. But let's say there's something inherent about the sort of the flow of the surface and its geometry, its internal geometry. So let's say I could begin to pull off isoparms, right? So here I can get the isoparms or even extract the entire wireframe if I want. Let's see here. Just trying to sort of find a couple of places where I can do that. See there. And let's say there. And let's say direction, I'll toggle now to V and get some vertical ones in there. I'm going to go ahead and use these to trim themselves up here. Try my best to select the curves and not the surface. That would be a disaster, wouldn't it? I'll go ahead and join these into one closed curve. And then maybe I just need to extrude this out or something to cut an opening or trim. Let's see, extrude, tapered, extrude, blah, blah, blah. I mean, there's a number of different ways you can do this. Now, I'm probably not going to extrude in this direction, the Z, that's interesting. Okay, so I'm going to go back out here to my 4 different vantage points and I'm going to change the direction and maybe do something a little more aligned with, with my geometry here. Oh, no, it still didn't work. When the heck in the... Oh, sorry. I'll try to act a little smarter. Direction. I'll turn off my ortho. Oh, it's already off. I'll turn off my object snaps, which seems to be throwing something off here. And I'll show direction. There we go. Again, I could always, do something like that, and then basically trim this crap out again. It's not crap, but you get the idea, right? I mean, trim, and then use this to trim that and that. And then again, if I needed to put some glazing in here, I'd probably turn on my midpoint snaps again. I'll turn off node vertex and end and just try to find some midpoints here. There's one. There's another one. There and there. Right. Now I have oh, no, maybe it's not a good idea to do that. Oh, so, that's interesting. Oh, wow. Huh. That's actually kind of funny. Here I thought I was being so coy and well, just like black box here and clever inside. But so how I would do that? That's interesting. There we go. I would just find, turn off midpoint here and turn on end. Now just start snapping this around, find isoparms along these edge surfaces that I made. And then just connect those up with, yeah, so make sure that this snaps the end of that other one I did. And do the same thing here, right? And hope that they all line up here at the very, very end. Please. No, they do. I don't think that's a coincidence. All right. So now I could take these and make a surface from 2, 3, or 4 edge curves, right? Let's see. Oh, it's right here. Boom. There we are. Ooh, ooh, ooh. All right. Cool. Yeah, that's what happens when you make something into something curved and it's the cuts are potentially curved as well. I should have known better than that. Again, if I just needed to trim this off, I mean, I could have done that again with the isoparms. But oftentimes when I'm working with surfaces, you know, and they're like double curvature, and you start trimming things away. You know, I try to get those isoparms to use those to trim. Then I can start to offset things into thickness, or bring things into Revit, or bring things into Grasshopper. Start to, you know, architect them a bit. You know, turn them into componentry.